Have you ever struggled to explain a complex idea to someone who isn't an expert? Whether it's describing how AI works, explaining a technical concept to your boss, or even teaching your kids how airplanes stay in the air. Breaking down complexity is a valuable skill. Today, we are using flight control concepts. Yay! To teach you step by step strategies for simplifying complicated topics. If an aircraft stays balanced at 30,000 feet using well designed control laws, you can definitely learn how to structure your explanation for clarity and impact. By the end of this episode, you'll have a framework to communicate even the most intricate ideas in a way that anyone can understand. Hello and welcome to MoloMolo, another episode of African Tech Stories. If you've ever felt frustrated trying to explain technical ideas to non experts, this episode is for you. Today, we're breaking down effective communication using flight control engineering concepts. Because if you can control an aircraft moving in the sky, 6 degrees of freedom, we can definitely control how we explain complex ideas. So, we're going to take this step by step in terms of strategies on how we can indeed simplify complex ideas for the layman. Number one, we need to start with the big picture. So, let's take this into consideration. Let's take an aircraft in flight. Before explaining stability, actuators, control loops, inner loop, outer loop, what's the most important thing? What's the big picture? An airplane flies because of four main forces: lift, weight, thrust, and drag. Now, we can go into much more details, but it's those four that fundamentally hold every single airplane in the air or in a specific maneuver. When explaining complex ideas, always start with the big picture. What's the main purpose? What problem does it solve? Why should your listener, you, care? If you're explaining a technical system, start with what it does before diving in how it works. So, number two, use analogies relating to everyday life. I love this one. Now, control laws in aviation might sound complicated, right? We talk about, I can go on and on for hours on end, and those who are watching this podcast might appreciate the fact that I've used control laws to try and explain how to explain complicated topics to in simple ways. But control laws in general is a very interesting but overly complicated idea. But at the core, they work just like, for example, riding a bicycle. When you steer the bike, you make small adjustments to maintain balance. If you overcorrect, you might fall. If you undercorrect, you might drift, of course. So, similarly, an aircraft control laws adjust the surfaces, called ailerons, which are used to bank the aircraft, or rather, used to steer the aircraft's nose to maintain stability and direction. So, when explaining a technical concept, find an everyday analogy that makes it relatable. A self driving car's control system, think of it like cruise control, but with a smarter system that steers for you. That's it. Number three, breaking it down into simple steps. Now, imagine teaching someone how a flight control system stabilizes an aircraft. Whoa, I remember the first time, and I can tell a story. In my third year at University of the Witwatersrand in Johannesburg, we had a course called Flight Dynamics. Oh man, was it crucial to understand and to really get grasp the concept of how an aircraft actually works. And it went into deep maths. And the reason why it's in third year, because it takes into account the maths of second year, takes into account dynamics of second year, takes into account all sorts of subjects that are relevant for you to learn how an aircraft flies. Now, instead of dumping all the information at once. We got to break it down step by step. Why? Because it's complicated. And complicated things can get out of hand even in our own minds. So, what's the goal? Keep the aircraft stable and on course, for example. which means it needs to be flying straight and level. What does it mean? It means you shouldn't be dipping in altitude, right? Essentially, if you were sitting in an aircraft, you shouldn't be feeling that you are descending or rising. Now, what's needed? Let's just say we need some sensors to measure movement and computers to process the data, and eventually actuators, which means just control surfaces on the aircraft to adjust the different positions. So, how does this work? The system detects, for example, any deviation and applies the right correction, just like a driver adjusts the steering wheel on a highway as soon as he sees a bump on the road or a hole on the ground. This step by step approach is called progressive disclosure. You reveal information in layers, making sure your audience understands each layer before you move on to the next. Now, if you take that into account, you can break down, for example, something called longitudinal dynamics and lateral dynamics of an aircraft into a very similar process where you start with what is needed and you go into how we're going to get what we need and explain the details of what we've used to get what we needed. Simple enough. Number four, use visual and physical demonstrations. Now, ever seen a pilot use a model airplane to explain aerodynamics? Yeah, I have, and I use it all the time with my 9-year-old. That's because visuals and physical objects make learning easier. If you're explaining stability, take a paper airplane, right? Everybody knows what a paper airplane looks like, and show how different wing angles affect flight. So, what does that mean? It means if you have a paper airplane where it's nice and slim and slender, what will happen is you will not always get a very beautiful set of flight. Why? Because you need to go really fast. Now, if you make the wings, each wing of the airplane, paper airplane, a lot larger, what you will immediately notice is that the flight is a lot more slower and a lot more beautiful, and the rate at which the airplane goes down to the ground is a lot more slower. That explains something called aspect ratio, which for some people, even in my own experience, still is something that is tough to grasp. See, in everyday tech explanations, visuals help, right? Instead of describing a software process with words alone, use things like flowcharts and sketches. Use programs like Matchchart or Overleaf or Google Docs and Google Draw, because when you do that, or even hand gestures, using hands, or just go onto a board to clarify relationships between components and systems. So visualization helps. Number five, connect to the real world applications. So now imagine you're explaining an autopilot system. Ooh, what is an autopilot? You might probably think an autopilot is a pilot that is on auto drive. Maybe. Now, instead of speaking about complex algorithms, connect it to something more practical, for example. Now, for example, have you used Google Maps, which has a turn by turn navigation? Autopilot works in the same way, right? Remember that blue arrow that, or whatever the color may be on your phone, that gives you a sense of where you should be turning? That's exactly how autopilot works. So instead, it's steering for you, right? So it's showing you where it's going and it's doing the action. So the aircraft follows a program route using the sensors and everything else around its environment to make a decision and automate the movement. See, relating technical concepts to familiar experiences makes them more digestible and memorable. So, having said that, now let's go into something quite interesting. We have a bit of an interlude and a bit of a light-hearted one. So, let's try and see. We've got a technical concept called feedback loops. Do you know what a feedback loop is? Hmm. Let's just see if we can think about it, and then we go. Have you thought about it? Okay, great. Now, let me give you one good example. Have you ever baked cookies? I love cookies, especially my wife's cookies, and checked the oven too many times, making them collapse. So, i.e., you've opened the ovens in and out and in and out and in and out because you don't really trust that you're doing the right thing. But at the end of the day, they collapse, i.e., they were not hot enough. That's a very poor feedback loop. In flight control, feedback loops are just inputs based on real time data. So if the airplane tilts or banks too much, sensors will detect it and the system will correct it to straighten level, for example. Just like adjusting your oven temperature if cookies are baking too fast. Very important concept. An airplane, autopilot, and feedback loop is just like you opening the oven too many times, causing the cookies not to bake as well. So, effective communication is a superpower. Yep, I've said it. Whether you're an engineer, a researcher, or entrepreneur, today we've covered key techniques, right? Starting with the big picture. Think of the big picture. Using analogies, breaking concepts into steps, leveraging visuals, and connecting to the real world and applications. Now, I've got a surprise. I recently finished a book. Yay to me. It's an ebook that you can get for free. I've made it available for all those who are interested in giving me feedback. So there will be a link with this podcast or this video where you can essentially grab a copy. Just leave your email and you can definitely download the ebook. It's essentially a story about a guy who goes through a maze and he struggles with self doubt and confidence and be able to speak up, technical communication and complex ideas, and goes and meets up different characters that will allow him to deal with those things, but also at the end of the day, give him a very big surprise about where do those characters actually come from. So I'm not going to spoil it. Pick up the book. The book is called Please Do Not Let Me Be Invisible. I think that's the title now. So definitely, I'm very excited about it, very excited about what you think. And again, thank you so much for the support for all those who have been supporting MoloMolo Tech Studios up to this point. So now we've talked about breaking down complex ideas. So if you want to improve how you explain technical ideas, whether for job interviews, presentations, or even team discussions, I offer one-on-one coaching at MoloMolo Tech Studios to help you, right? So we sharpen your technical storytelling skills, to engage a different audience. We simplify simple ideas, complex ideas through without losing depth. So we really go into a very pragmatic approach where we try and prioritize, we try and give a sense of collaboration, and but more importantly, we open up the need to be clear and concise. We also go through very strong and develop strong visuals and demonstration to reinforce specific learning points, where we also leverage your strong point, which sometimes is so crucial. So this all boils down to you growing and speaking with clarity and confidence in every professional settings. So again, if you're interested, click in the description below for a free strategy session. We'll go through a technical assessment and you will be able to start leveling up your communication skills as I walk you along right through it. So in recap, start with the big picture. Define the why before the how. Use analogies. Relate new ideas to familiar experiences. Break it down into steps. Unpack complexity progressively. Leverage visuals and thought processes that can be easily explained and demonstrations. Seeing is understanding, specifically for those who are non technical. Connect to real world applications, right? Make it practical and relevant. Master these techniques, and I promise you, you'll make complex ideas not even simple, but engaging and memorable. This is another episode of MoloMolo African Tech Stories. I'm Dr. PK. Until next time, ciao.